society. Now we are back with another topic, which is a chain rule, that how to apply a chain rule. As we know how to differentiate this type of function, as if we have a function g of x which is equals to x square minus 4, and we have a function which is f of x which is equal to sine of x. As we know to differentiate this type of functions, but what to do when we have to differentiate composite like functions, like for example f of x, which is a function with another function like this, which is equals to, if we write as sine x square minus 4. But what to do when a function of a function? So as differentiation formula do not tell us how to calculate a composite functions, mean how to calculate the derivative of this function. So here is a question, how to find it. The answer is very simple, to apply the chain rule. As the chain rule helps us to differentiate composite functions. When a function, this is the outer function and this is the inside function. So basically chain rule helps to differentiate composite function. In other words, we can use chain rule when we differentiate a function of a function like f g of x. In what situations we apply the chain rule? For example, if we have some situations. For example, if we have these four situations, here we do not apply the chain rule because it is very simple, and in that case we do not need to apply the chain rule because it is not a composite function, it is a simple function, and in that case no need of apply the chain rule. But in this case there is a need to apply a chain rule because this is the inner function, x square plus 1 is the inner function and the whole power of 7 is the outer function. In this function we can also apply the chain rule, as this whole part is the outer function and this part will be the inner part of the function. Now to take some examples that how to apply the chain rule and in which situation. So here is a first example, that is this part is the inner part and whole power with is 9. So in that case we apply the chain rule. First of all, suppose the inner function, let for example we suppose u which is equals to only this part which is inner part, x cube plus 1. Then after this supposition the y becomes, if this part is u, then we can write u ki power 9, u is power of 9. Now we have to calculate dy over dx. What the chain rule says, if we calculate this term and we involve this variable u, so we apply the chain rule, dy over du, multiply this factor with du over dx. So basically we calculate this factor, and let's suppose we say this is the first equation and this is the important step of the chain rule. So as we have to differentiate the factor u with respect x, so we differentiate this factor with respect x. So we have du over dx, which is equals to derivative applied on both sides. So we have, by applying the power rule, it will be 3x square and the derivative of any constant term is 0. Now the second factor we require, so taking derivative on both sides with respect to u, so we have du into u power of 9. So again by power rule, 9u 8. Here we already suppose this value, so we put this our supposition value which is x cube. What's the u? U is x cube plus 1. Here u is power of 8, so we can write as. So put the values in the first equation. So we have dy over dx, which is equals to, what's this factor, which is this 9x cube plus 1 8, multiply with this factor 3x square. So what's the final answer? It will be 27x square x cube plus 1 8. Here is another example of the composite functions. Here this is the inner function and this is the outer function, which is the radical sign. So we can write this term. So now it look clear. So how to differentiate this term? How to calculate dy over dx in this question? So it looks so tricky to solve the derivative, but the chain rule helps us to solve it very easily. So let's start. Suppose that u, which is equals to 1 plus x and divided by 1 minus x. If we suppose the inner term, then the y becomes y, which is equal to u1 over 2. The chain rule says if you involve any variable, you will involve, let's suppose, w. If we suppose that this factor is w, then we have to calculate this factor. So the chain rule says that differentiate dy over dw. Suppose any variable what you want. So multiply dw over dx. Basically this is the chain rule. Suppose this equation is 1. Have to take derivative with respect w. So we can write as w 1 over 2. So 1 over 2 w 1 over 2 and with minus 1. So we are left with 1 over 2 w minus 1 over 2. Is a very big mistake that someone not put the value whatever you suppose. So what's the value of w? Here is a w. So 1 plus x and 1 minus x with power of minus 2. dy over dw, which is equals to 1 over 2 and 1 divided by multiply 1 plus x divided by 1 minus x, 1 over 2. The next step, we have a final answer 1 minus x divided by 1 plus x with power of positive 1 over 2. Now we have to calculate this factor to take derivative with this factor with respect x. So we have, as we here apply the quotient rule, how to apply the quotient rule, the link is in description for the complete video how to apply a derivative of the quotient factor. The term which is in denominator, write it simply, multiply the derivative of the term which is in the numerator, so it will be 1. The sign between them is minus, and then the term which is in numerator, write it simply, 1 plus x multiply derivative of the term which is in the denominator, which will be minus 1, divided by the square with the term is in the denominator, 1 minus x, and it will be plus 1 and plus x divided by 1 minus x square. This x is cancelled out, so it will be 2 divided by 1 minus x with square. So now put the values in the first equation as dy over dx, which is equals to, what's the value of here? Here is the value of 1 over 2. Here 1 over 2, 1 minus x, 1 plus x with this term. Multiply this factor, 2 divided by 1 minus x square. 1 divided by 1 plus x, 1 over 2, multiply, if we move this factor, so we can write as minus 1 over 2. So 1 divided by multiply sign 1 minus x square. It will be 1 plus x, 1 over 2, 1 minus x, 3 over 2. So here is a final answer of this question. So here is the last example of today's lecture. So as this type of function, that this is the outer part of this function and this is the inner part, as a trigonometry with is in another trigonometric function. So how to solve this type of function? So the answer is by chain rule. Basically this whole part is the outer part and this is the inner part. So always remember that let suppose the inner part of the function which is equals to u, which is equals to 5 minus sine 2x. Then after suppose this value, what we are left with y. So y becomes tan of simply u, and we have to calculate dy over dx. If we involve this any variable, so our formula by chain rule says dy over du multiply du over dx. Suppose a equation. First we take the derivative of this factor. So we take derivative on both sides. So derivative of tan of u, as the derivative of tan of u is secant square of u, and always our supposition value of u must put here. So secant square, and what's the value of u? Here is the complete value of u, 5 minus sine 2x. To compute this value, So taking derivative on both sides with respect x. So we are left with the derivative of the constant term is 0 minus the derivative of this factor, derivative of sine is cos 2x and the inner term is 2. So multiply here add. So we are left with minus 2 cos 2x. Now put the values in the A equation. So we are dy over dx, which is equals to, what's the value of is secant square 5 minus sine 2x, multiply this value which is minus 2 cos 2x, and just to simplify this term we have minus 2 cos 2x secant square into 5 minus sine 2x. Basically the chain rule says that the derivative of the outer function remaining the inner function alone multiply the derivative of the inner function. So in this way you can solve any tricky questions. So here is a complete procedure of applying the chain rule. Basically chain rule helps to differentiate a composite like functions. Here is a very big question that when we apply the chain rule. So answer is very simple. Whenever you face a composite like functions, and always apply the chain rule. If you like this video, then don't forget to subscribe and click bell icon for more videos.